Hello, this is the second lesson on the Chatelier's principle. If you haven't watched the first one yet, I suggest you do so. This lesson is looking explicitly at exam questions using the principle, and if you haven't revised the principle, it's not going to make much sense. May I also suggest to get the most out of this lesson, you pause the video before each question, you answer the question as best you can, and then you learn from your mistakes as I go through the answers. I am going to have to talk quite quickly in order to get this fitted into 10 minutes, so do try to keep up and pause when you need to. Okay, so let's start this question here. Pause if you can. If you're really not confident, just follow along for now. Okay, I'm going to bug the question to make sure I'm happy that I'm going to get all the marks possible and I know exactly what I'm doing. So there's a question here, what will happen to the position of equilibrium if the temperature is increased? And I've got a command word there, explain your answer. So I'm going to have to give a reason if I want maximum marks. So what will happen to what? Well, the position of equilibrium. So that's going to either be left, right, more reactants, more products. And what am I changing? Well, I am increasing the temperature. Well, before I go any further, I need to know whether the forward reaction is endothermic or exothermic. And it tells me that here the reaction is endothermic in the forwards direction. So I'd be annotating this on a piece of paper somewhere, guys, which means the reverse reaction is exothermic. Okay, so I'm going to use my dual coding. What am I going to do? Well, the question tells me I am increasing the temperature. Okay. So what will the reaction do? Well, it will do the opposite, as they always do. It will move to reduce the temperature, or it will decrease the temperature. So if I think about that logically, if I'm reducing the temperature, it's getting colder, that's endothermic, which I know is the forwards reaction, in which case equilibrium moves to the right. Let's give a reason for that to pick up extra mark. The forward reaction is endothermic, so it's going to go to the right, and therefore I would make more products. Okay, again, pause the video if you think you're confident on this, follow along if you're not. So again, I'm going to book the question. It says here, explain. So I'm going to have to give a reason, explain what would happen to the position of, equilibrium position. So again, left or right, and to the yield of PCl5. So if I look at the equation, the PCl5 is the product. So what will happen to the yield of the product? So that just means how much product I'm going to make. Am I going to make more product? Or am I going to make less product? Well, what am I changing? I am changing the pressure. I'm increasing the pressure. Okay, right. So before I go any further, I need to know where the natural high pressure is and where the natural low pressure is. So I'm looking at equation. On the left-hand side, I can see I've got 1 mole of PCl3 and 1 mole of Cl2. So that's 2 moles there. And on the right-hand side, I've just got 1 mole of the PCl5. So high pressure is on the left and low pressure is on the right. Let's use dual coding. What am I doing? Well, the question says I am increasing the pressure. So what will the reaction do? It will decrease the pressure. So if it's decreasing the pressure, so it wants to go to low pressure, decreasing pressure, low pressure, that's where there's 1 mole rather than 2. So that's again to the right. So equilibrium moves to the right. Give my explanation. There are fewer moles or there is lower pressure. Both of those would get the mark, and therefore I end up with more product. Okay, have a go at this one yourselves, guys. Notice this is a multiple choice question and it is asking you to do 2 things. It's asking you for a higher temperature or a lower temperature. So 450 is the high temperature, 250 is the low temperature. And it's also giving you a high and a low pressure. 250 atmospheres is the high pressure, 1 atmosphere the low pressure. And so you're having to change 2 things. So bear that in mind. So if you're happy, continue. If you're not, follow along. Okay, so it's saying to me, what have I got to find out here? It says, which set of conditions gives the highest percentage yield of sulfur trioxide? So which of these conditions, high temperature, high pressure, low pressure, is going to give me the most sulfur trioxide? And sulfur trioxide from the question, I can tell is the product. So by changing temperature and pressure, which one's going to give me the most product? So let's look at this equation. So let's break this down. Temperature wise, so let's look at temperature. I need to know which way is exothermic, endothermic. It tells me here. Forward is exothermic and therefore reverse is endothermic. Right, okay. So I want this reaction to make more product. So I want the reaction to have a higher temperature. So I'm going to tell it to go low. So I follow that through. I do low temperature. So reaction does a higher temperature, which is exothermic, and therefore makes more product because it moves to the right. So I want a high temperature. Sorry, I want a low temperature, which is this one or this one. Okay, so I'm 50-50 chance now. Am I going to keep going? Yes, I am. So pressure, I need to know where my high pressure, where my low pressure is. That there has got 3 moles, that side has got 2 moles. So my high pressure is on the left, my low pressure is on the right. So I want the low pressure because that's going to move it to the right and give me more product. So if I want the reaction to be low, I'm going to tell it to go high because it'll do the opposite. So I want it low, so I'm telling it high, which is this one here, which gives me the answer B. A lot going on there, guys, just for the mark. Okay, let's look at this question. Again, pause and have a go yourself if you're feeling confident. So it says, amongst other things, predict the effect of adding more oxygen to the equilibrium mixture and explain your answer. Now, normally I'd read the entire question, but I am running out of time, so moving on quickly. Okay, so if I'm adding more oxygen, if I look at the equation, that is more reactants. So if I, think of my dual coding, if I am increasing the concentration of reactants, the reaction will move to reduce the amount of reactants and therefore make more product. So equilibrium is moving to the right and I'm making more sulfur trioxide. So just think of that dual coding. What have I done? What did the reaction do? Equilibrium's moved to the right. I'm making more product. I'm making more sulfur trioxide. What did the exam board say? Equilibrium moves to the right. They've said use to Y to remove added oxygen. But if you look at the allow here, it said allow more product or more sulfur trioxide is made, or it favours the forward reaction or increases the yield. So you would have got both marks there if you'd have got both of those correct. Just notice here, guys, it is an aside, it's not part of this question, but this question was part of a bigger question originally. That minus 196 kilojoules per mole tells you that that is an exothermic reaction. So you'll notice here it doesn't say whether there's an exothermic reaction or an endothermic reaction. You would need to know from that data there. The minus is exothermic. It doesn't tell you whether it's forwards or reverse, so you would assume it's the forwards reaction. So that information is telling me the forward reaction is exothermic. Okay, so this is the second part of this question here. It says predict the effect of increasing the total pressure in the equilibrium mixture, and explain your answer. Okay, so pressure, we're going to need to know about moles. There's 3 moles there and 2 moles there. So the high pressure is on the left, low pressure is on the right. If I increase the pressure, so if I'm increasing, the reaction will decrease. That's moving to the right. So equilibrium will move to the right and we'll end up with more product, more sulfur trioxide. Why? Because that's where the less pressure is. So what would we get for the mark scheme there? Equilibrium moves to the right. 3 molecules or moles to 2 molecules, reducing the pressure. So anything that talks about, there's less moles on the right hand side would get that. If you look at the allow there, fewer molecules, fewer moles on the right hand side. Yeah, so I think we probably pick up, I'm just trying to look there, I think we've got both answers there, so yay. Okay, so let's finish off. This is a 6-mark question, and I would like you please to have a go yourself. I'm not going to talk you through it. The mark scheme is on the next slide, so you can check yourself. Let's just bug the question so you know what you're doing. It says predict, it says explain, so you're given a reason. Position of equilibrium, so left or right, more reactants, more products. What are you changing? Well, the first paragraph, you're going to increase the pressure. The second paragraph, you're going to increase the temperature. And the third paragraph, you're going to add carbon dioxide. If you look at the reaction, the carbon dioxide is one of the reactants, so you're increasing the concentration of reactants. How do you know if it's endothermic or exothermic? It says it here. Notice it doesn't say forwards or reverse. You would assume it's forwards unless it says otherwise. So this is exothermic in the forward reaction. Have a go and check the mark scheme at the end. Okay, here's the mark scheme. Did you use the correct language? Did you get them the right way around? If you did, well done. If you didn't, learn from your mistakes, guys. It is a work in progress.